Hey guys, in this video we will discuss about one-dimensional Dirac Delta function. So, in the previous video we have already seen the need and importance of Dirac Delta function that we have seen in the introductory video that you can see. Let me show you what we have discussed in the previous video. We have taken a vector function 1 by r square r cap, and through that I showed you the importance of Dirac Delta function. Okay, let's discuss one-dimensional Dirac Delta function. So a one-dimensional Dirac Delta function can be imagined as a infinitely narrow and a infinitely high function. It is infinitely narrow and it's infinitely high, so consider it as a infinitely high and it is infinitely narrow and with area 1. Okay, so it is defined like, let me define it. It is defined like, and it is denoted by del. It is defined like del x is equal to 0 if x is not equal to 0. Okay, at except at 0, except at the point 0, at all the other places the value of function will be 0, and it will be infinity if x is equal to 0. Okay, let me shift it like that. Okay, and the value of function will be infinite at point x is equal to 0. And one more property is that the area under the curve is 0, so we can express it like this. Okay, so we saw that how the function is defined, and we saw one of its property. Okay, if technically speaking, it cannot be called a function, because the condition for function is that it should be finite at all the points, but at one point the value of this function is infinity. So in mathematical literature this kind of function is known as generalized function or distribution. So, okay, now let's see a important property of delta function. Let's consider a function fx. It is a general function which is continuous over its domain, and let's multiply it by del x. So we can write these things like f0 del x. Let's understand carefully how we can write it like this, because except at the point x is equal to 0, this multiplication is going to be 0 because del x is 0 for all the other points, and at x is equal to 0, this we can write it like this. So we can substitute the value of function which it attains at 0. Except 0, this multiplication is going to be 0 because del x is 0. So it does not matter what we can replace here, and f is equal to 0, we can write it like this. So this is a very important property, and by using this property, let's see what we can write. If we integrate this multiplication, then as we can write it like fo, and we can take it outside the integral, and in bracket we got del x dx, and from the first property we know that this is 1, so it will be f0. So it means that under an integral the value of the delta function picks out the value of fx at x is equal to 0. Here one more thing to note, that it is not necessary that the limit of integral should from minus infinity to infinity. In fact, it can be any minus epsilon to plus epsilon. So it is sufficient that the domain extend across the delta function. The domain should extend across delta function. That is the only sufficient condition. No need it to be from minus infinity to plus infinity. Okay. Until now we were only talking about the point x is equal to 0, but we can also shift the spike to any other point x is equal to a. So let's see that. If let's say we generalize, we shift our x is equal to a. We have shifted the spike from x is equal to 0 to x is equal to 8. Now the function will be defined as del x minus a is equal to 0 if x is not equal to a, and it will be infinity at x is equal to a. And the second property can be written as minus infinity to infinity del x minus a dx 1. Okay, so we have also generalized our delta function, and this property can be written in for this function like del fx del x minus a can be written as fa del x minus a, and at last if we integrate these sum these multiplication, then it will be fa. It will attain the value of function at that point a. Okay, let's take an example. Let's take an example. We have to evaluate the integral from 0 to 3, limit is from 0 to 3, x cube del x minus 2 dx. Okay, see, in this case the value of a is 2. Okay, and see, the limit takes a is inside the limit, so this integral will take the value of function at point 2, so it will be 2 to the cube and answer will be 8. So see how by using this property we have solved this answer. Solve this question just in one line. One more last point to note is that although the Dirac delta function is not a legitimate function, integral over del x is completely fine, and most of the time the Dirac delta function is used inside an integral. So inside integral they are perfectly fine. So that's all for this video, guys. In next video I will generalize this function in 3 dimension. Okay, thank you guys.